Good morning, students. Today we will discuss about artificial neural network concept and its related lab program. Okay, what do you mean? So today's outlines are the introduction about artificial neural network and what is how neurons will be represented and how artificial neural networks works and what are their different activation functions and perceptrons and web propagation algorithm. These things today we will discuss. Okay, so first, what do you mean by artificial neural network? Okay, so ANN we will simply call it as a ANN. What is ANN? ANN is nothing but an artificial neural network. How human thinks now, like that, the computer will also think and it will take the decision. So for that, we need this artificial neural network. This is invented by first neurocomputer. Okay, is Dr. Robert H. Nielsen. Okay, so he is the scientist. He developed the first neurocomputer that is based on artificial neural network. The ANN is nothing but it is a computing system made up of a number of simple, highly interconnected processing elements. Okay, so a number of processing elements are interconnected. Okay, so which process information by their dynamic state. Okay, so these information will be processed by their dynamic state to external inputs. Okay, for external inputs we have a number of interconnecting processing elements. They are processing that information by dynamic state. Okay, that processing elements we are calling as a neurons. Okay, so this is a neurons. This is by how so this ANN is concept of the how human brains thinks, no, like that. The computer system also will work with the think and it will take the decision. So it depends upon our human brain. So in human brain, the basic element is neuron. So this is the part of neurons. Okay, in our brain. So when you take the neurons, we will have a dendrites. Okay, so this receives these signals from other cells. Okay, and this is the cell body. This organizes keep all functions. Okay, so this is the nucleus. This is the center. Okay, controls the entire neurons. Okay, so then this one will cut the axons. Okay, transfer the signals to other cell, and this is axon terminal. Okay, so forms the junction with other cell. So these are the things, the dendrites, axons. Okay, and nucleus are very important. Okay, so then cell body keeps organized and keeps the cell function. Same thing we are converted that one our neurons in our artificial neural net, that one we will call it as a perceptron. Okay, so here this is the how one single neuron. This is the dendrites. Dendrites are nothing but a inputs. Okay, so then after that, this is cell body is nothing but a processor. Okay, and axons is the output. Okay, so we are converted that one into dendrites and cell body and the axons into our artificial neuron. Okay, so dendrites are nothing but input, cell body are nothing but processor, axons are the output. Okay, so this is a new neural network. That is, neural network are made up of many artificial neurons. Each input to the neuron has its own weight. Okay, so for each input of the neuron has its own weight associated with it, illustrated by the red circle. These are nothing but weights of the each input of the neuron. Okay, a weight is simply floating point number, and it's these we adjust when we eventually come to try the network. A weight is simply a floating point number. Weight will be a simply floating point number, and it's these we adjust when we eventually come to the come to train the network. So at that time we need to adjust these weights. Okay, when you take a single neurons, okay, we'll have a number of inputs. Okay, they're from x1 to x5, and each one having a corresponding weights. So what we are doing, we are multiplying this input with the corresponding weight. After that, we are like that we are inputting all the inputs with the weights, corresponding weights, and we'll make a summation function. After that, we are transferring a representation form using some activation functions. So then output will be fed to other neurons. So like that, we will that inputs and weights will be multiplying, and we are summation. After that, we are transferring that one to another form. That one will be sent to other neurons through output. Okay, how artificial neural networks will work? Okay, so let us. This is the model what I have discussed. Okay, how we so this is an inputs. Okay, so in processing we will have inputs having the weights. Okay, so and after that here we are having a summation function, then that will be output. Okay, so that is it will be sigma is equal to x1 plus x2 plus xn. If you have a weight, it will be w1 into x1, w2 into x2 plus w3 into x3 plus xn into wn is equal to yn to the output. Okay, so this is the neuron, whatever it is. So these are the inputs. We'll have n number of inputs we have from x1 to xn. Okay, and each one having a corresponding weight. Okay, so here what we are doing, so and we are having x1 into w1, so we are multiplying, we are summation those things. Okay, so and after that we are adding that bias. Okay, so bias has some numeric value. So then after that we are doing all those things into summations. So that is input with the weight, and we are summation all those things with the bias, and after that we are converting that one into a another form using this activation function. Okay, so representation for one form to another form, so it should be understandable by other neuron. Okay, so that output will be understood by other neurons, so we are converting that one into a specific form using activation function. That one output will be get, that output will be fed to another input to the another neuron. Okay, so what are those activation functions? So here activation functions we are using three types, three common types: step function, sign function, and sigmoid function. Okay, so an output one represents firing of a neuron down to the axon. Okay, so these are the three functions what we have: step function, sign function, and sigmoid function. What is step function? If the output of x is equal to 1, if x threshold is greater than 1. So if x threshold value, that if x is greater than or equal to 1. So that is we call it as a linear threshold function. So here what we are doing, so here we will put a one threshold, it may be 0.6 or a 0.7 or a 0.8, whatever it may be. So after summation of the input with the weights, okay, with the bias. So if that value is greater than that threshold, it will be 1, otherwise it will be 0. Okay, so that one will call it as a step function. Then sign function. In sign function, if the x value, that summation value is greater than 0, greater than or equal to 0, it will be +1. If it is less than 0, it will be -1. That is sign function. The sign function is nothing but plus or minus. And sigmoid function. Sigmoid function will 1 over 1 power 1 over 1 plus e power minus x. So it will be varies from 0 to 1. The values will be varies from 0 to 1. It will be 0.1, 0.2, 0.5, 0.6, 0.10, 0.10, 0.98. So like that it will be varies. So usually we will use the sigmoid function in artificial neural network. Okay, to represent the data in the form of 0 to 1, in the range of 0 to 1. The standard structure of an artificial neural network is input units, hidden units, and outputs. Three units are the input unit, hidden unit, and output unit. The input units represents the represents the input as a fixed length vector of numbers. Okay, so here here we have a fixed length of vectors. So it may be one neuron, two neurons, or three neurons, whatever it may be. Then hidden units calculate the threshold of weights of some of the inputs. So it calculates the threshold of sum of weights and represents the intermediate calculation of that network. Okay, so then the output will be represents the a fixed length of vector. So it may be an input, output, and we may have different varieties of neurons are there. Varieties means different numbers of neurons are available in these things. Okay, so this is the types of layers, input order. So in input layer we have three input neurons. Okay, so in hidden layer 4, and in output we have 2 neurons. So that is the input to the hidden layer is output of the input layer. Then output of the hidden layer will be the input to the output layer, output neuron. Okay. How actually use the an artificial neuron? So here we have a feed-forward network. In this feed-forward network, what we are doing, the neurons in each layer is fed to their output forward to the next layer until we get the final output from the neuron. So here, whatever this input layer, the input layer will be the the output of this input layer will goes to hidden layer. Then output of the hidden layer will goes to output layer. Okay, so like that, we are neurons in each layer is feed their output forward to the next layer until we get the final output from the neural network. There can be any number of hidden layers that can exist within a feed forward network. It may be one hidden layer to n number of hidden layers we may have. The number of neurons can be completely arbitrary. Okay, the number of neurons completely arbitrary. It will be independent. We'll choose based on that requirements. So this is the how that same neurons will be represented in artificial neural network as a perceptron. Okay, so one type of artificial neural network is based on the unit called perceptron. This is the basic building model of a neuron will be the basic building block of a neuron will be the perceptron. Okay, so artificial neuron, the brain basic building block is neuron. Same thing we are converted that one into artificial neural network. It will be, we'll call it as a perceptron. So here we have a n number of input. This is 1%, the representation of 1%. So here we have, for that percentron we have a n inputs, x1 to xn input. For each one we will have a weight, and here we will have a bias also. So here we are multiplying, we are so x naught, w naught, we are multiplying input with the weights. Okay, after that we are summation we are doing here, and after that we are converting into another form using activation function. That one will be the output. What? So here we are using the sine function. If wix, that is summation, is greater than 0, it will be 1, otherwise it will be -1. You can use sine function or a sigmoid function, okay, or a threshold function you can use. So usually in our program we are using sigmoid function, 1 over 1 plus e power minus x. Okay, so here the input x1 through xn, the output o of x1 to xn is computed by the perceptron. Okay, so same thing. So you are multiplying this now. So okay, the same thing, we are multiplying x1, x1 with the w1 will be multiplied, and summing with x2 w2, like that. We x1 wn, we are summation this thing, and we are putting activation function, we are getting the output. So here if if w naught plus w1 x1 w plus x2 plus w into xn, it will be greater than 0, it will be 1, otherwise it is the sine function we are giving. Then we will come to backpropagation algorithm. So this backpropagation algorithm learns the weights for a multi-layer network, given a network with a fixed set of units and interconnected. So here backpropagation algorithm, it learns the weights for a multi-layer network. So here we are using a multi-layer network, and here it learns the weights for a multi-layer network. This backpropagation algorithm, and given a network with a fixed set of units and interconnections. So here we have a fixed set of units and interconnections. It employs a gradient descent to attempt to minimize the squared error between the network output values and the target values of these outputs. So here we have a target value. So we need to reach nearer to, at least nearer to target value by using this backpropagation algorithm. So for that we will have a concept called gradient descent. So it is used to minimize the squared error between the output value of the artificial neural network and the target value of the output. Okay, so to minimize that error, we are using this gradient descent. Okay, so what is gradient descent algorithm? The backpropagation calculates the gradient descent of the error of the network regarding the network modifiable weights. So here we are to improve the accuracy. So we need to refine the weights. So how we need to adjust the weights. So to adjust the weights, we need to minimize the error. Okay, to minimize that error, we will have a concept of gradient descent. So here we will have a, for that we need to modify the network, modify the weights. We need this gradient descent algorithm. The gradient descent almost always used in a simple stochastic gradient. This gradient is almost always used in a simple stochastic gradient descent algorithm to find the weights that minimize the errors. Okay, this stochastic gradient descent algorithm are used to get the weights to minimize the errors in that way. Okay, so here we have a how that this gradient details will be representing using this diagram. So here we have a different ways that weights errors should be minimum. Okay, in that backpropagation algorithm, it can be divided into two phases. First phase one is propagation, that is forward propagation, and so in that, and after that we have a backward propagation. So here forward propagation. So in that forward propagation of a training patterns input through the network in order to generate the propagation output activation. So here we will go from input layer to output layer, that is forward. Okay, in each layer we will have an input Okay, so that input will be calculated in hidden layer. That one will be the calculated in input layer. That one will be the output to the hidden layer. Then hidden layer will calculate. Then output of that hidden layer will be the input to the output layer. Okay, that is nothing but a forward propagation. Okay, so in backward propagation of the propagations output activations through a neural network using training pattern target in order to generate the delta, that is difference between the input and output values of all the outputs and hidden layers. So here what happens, we will get an output response. So in that we will have a difference between the expected output and the expected target values with the whatever we are getting output. We will have a difference. To minimize that difference, we will have a back propagation. So like that we need that will forward from the the output of the output of the output layer will be the input to the hidden layer. The output of the hidden layer will be the input to the input layer. Okay, so we will we will come reverse. Okay, so like that we need to minimize the error. Okay, we need to minimize the error between the target value with the expected output of our model. Okay, in phase 2 what we are doing, we are updating the weight. When you update the weight, then only you will get the accuracy result. Okay, so here we will multiply its output delta and input activation to get a gradient descent weight. Okay, when you multiply its output delta and the input activation, we will get a gradient descent gradient of the weight, that is we will get a adjusted weight. This subtract a ratio of the gradient descent from the weight. So we will, whatever the subtraction we are getting from the whatever we are getting from the gradient details will be subtracted with the weights. We will get a new, that error will be get, from that error we will adjust the next weight. Okay, so like that this proper back propagation algorithm works. That is feed forward, back propagate, and update weight. That's all. Okay, so like that we will n number of times, n number of iterations we will compute. Okay, we will execute, finally we will get a result. Okay, so propagating propagating forward, how that will so here we input layer, this one will be the output of input layer, will be the input to the inner layer. So in that we are after input layer we are calculating the sigmoid. So after applying the sigmoid function, we will output of that sigmoid will be the input to the internal nodes or a hidden layers. Then we will process process that was the output of the internal layer, that is will calculate through sigmoid function. After that, the output of that sigmoid function input, it will be the input to the output mode. Okay, so like that we will that feed forward will be executed. So number of hidden units, it may be vary. Okay, so the hidden layer, you may take one hidden layer or you may take 10 hidden layers. So because due to that result, based on that result. Okay, the number of hidden units is related to the complexity of the decision boundary. That is very it will be depends on complexity of the decision boundary. If examples are easy to discriminate, a few nodes would be enough. Controversially complex problems requires many interlayers. So it depends on your problem situation. Okay, if the problem is more complicated, then increase the hidden layers. If it is very less, you can use one or two hidden layers. The rule of thumb is to be chosen roughly, that is roughly by m by 10 weights, where m is the number of training examples. Based on the training examples divided by 10, we can choose the weights. Okay, that value you can choose for the weight. Okay, so this is the theory concept. Now I will discuss a back propagation algorithm in a lab program. So this the problem statement is build an artificial neural network by implementing the back propagation algorithm and test the same using appropriate data set. So here we need to build the artificial neural network by implementing back propagation algorithm. Using back propagation algorithm, we are implementing artificial neural network. So then after that we will test the same using appropriate data. Okay, so this is your problem statement. Now we will discuss about program. So this is the lab program. So here we are importing NumPy. Okay, numpy as np. So here these are the here we are taking 3 input neurons in an input layer. Okay, sorry, 2 input neurons, 3 hidden layer neurons, and 1 output neurons. Total 6 neurons we are taking. Okay, so in input layer 2 neurons, hidden layer we are taking 3 neurons, and output layer one neuron. Total 6 neurons. So for that these are the values 1 to 1 2 9. Okay, so we are declaring the array, we are initializing the array. Okay, new numpy array. So 2 9 1 5 3 6. Total there is a data type is float. So we are declaring 6 values, and we are made it as a one array. It is stored in the x. This is the actual output. So this is the output values 92 86 89. So this is the output value. Okay, so this one we are converting maximum x-array longitudinally. So that is that input divided by np of a of max. Okay, so the which is the maximum value. From that we are dividing that particular value. Okay, and we are output will also divided by y divided by 100. Okay, so it means we will get a, this is the okay, whatever input we are taking 29. Now actual input will be the this one. Okay, so 0.66. So instead of 2 we will have a 0.66, then 9 it will be 1. Okay, so maximum value is 9, that is 2 divided by 9 it will be 0.66, 9 divided by 9 it will be 1, and 1 divided by 9 will be 0.33, 5 divided by 9 is nothing but a 0.555, and 3 divided by, okay, so 3 divided by 9 and and 6 divided by 9. Okay, so this one will be the output. Okay, so then this one will be the input. Okay, after that, so here we have a output will be divided by y by 100. It will be when I divided by 92 divided by 100, this is the actual output 0.92, 0.86, and 8.89. Okay, so now this is the sigmoid function 1 over 1 plus e power minus x. That is this is the definition of a sigmoid function. So we are using sigmoid function. So then this is this derivative of sigmoid function. So that is derivative of sigmoid functions. We are x into 1 minus of x. Okay. So now here we are initializing. So epoch is nothing but a number of iterations. So 7,000 iterations we are doing. So that is feed forward, back propagate. The 7,000 times. See, think it is 7,000 times we are. And here learning rate will be the 0.1. So here number of input layers will be 2, number of hidden layers, number of hidden layer neurons will be 3, and the number of output neurons will be 1. Okay, and for that, for each one we need to assign the weights. Okay, so here we have input. So for that we need to initialize weights. So we need to calculate multiply with input with the weights. Now, so here randomly we are initializing weights. Okay, so for input layer neurons and hidden layer neurons, we are initializing the random values using np random uniform. That size is equal to how many input layers are there, how many hidden layers. Okay, so that one we are weights and initializing. Like that for bias also we are initializing. Okay, np.rat size is equal to 1 hidden layer. For hidden layer neurons we are applying the, we are taking the bias. And for output, okay, so then output weights will be the, for hidden layer neurons and output neurons it will be the weights. Okay, we are initializing, and like that the bias of output layer neurons also we are using the random function we are initializing. Okay, so that weights and so we got a input neurons values here. Okay, so we have a 6 neurons. For that we have a inputs and we have a weights. Okay, so now we need to calculate the, so what we are doing for I in the range of epochs, so 7,000 iteration, we need to do these things. So here first thing is what we need to do, we need to multiply input with the weight. So that one we are doing here, np dot. So dot is nothing but a multiplication of x input with the weight, corresponding weight. We will get a summation of a multiplication of input with the weights. So then after that we are applying the bias. We are adding the bias. Okay, so then after adding the bias, we are applying the sigmoid function. Whatever the values we are getting after that multiplication of input with the weight. Okay, after summation of summation of those things. After that, we are adding bias. Okay, after that adding bias with that summation, we are applying the sigmoid function. Once that is sigmoid function is 1 over 1 over 1 plus e4 minus x. That one will, when we apply that sigmoid function, this is the output of input layer. Okay, that output of the input layer will be putting with the weights out. Okay, so that one will be the input of hidden layer. Okay, input of hidden layer. Okay, so then that same thing what we are doing, so we are multiplying with whatever we are getting output, that one will be multiplied with w out. Okay, so weights of output, uh, weights of that output layer. Okay, so our w out is our weights of hidden layer, hidden neurons and output neurons. So that one will be multiplied with whatever the input of first layer, that is input layer. Okay, after that we are applying the bias. So once we get the summation, we are applying the bias. Then after that applying the bias, we are applying the sigmoid function. Okay, so now we get the output of feed forward. Okay, so now we got the output of feed forward. Now we will apply the back propagation algorithm. So here back propagation algorithm, this is the expected output. Y is nothing but the target values. So here, what is the difference between the target value with the what we are getting output of our model? So y minus this is nothing but an error. So we need to work minimize the errors using back propagation algorithm. Okay, so here we are applying the derivative of sigmoids of output, whatever we are getting as output. So then after that, we are multiplying with the that error rate, error, whatever we get a y minus output. So that whatever errors we are getting, that one will be multiplying with derivative of output. Okay, so this is output is nothing but a target minus whatever we are getting output, that value will be multiplied with whatever derivative of that output. Okay, so once we get that d output, that is multiplication of that error with the derivative of output, we are multiplying with, that is the input. Okay, so that one will be multiplied with the weights. Okay, so that one will be multiplied with weights. Then after that, whatever we are getting the output of EH now. Okay, so here we are applying the derivatives of sigmoids of H layer act. Okay, so the previous H layer act whatever we have now, so this H layer act now, so for that whatever we are getting sigmoid function, that one we are applying the derivative of that. So here we are getting a hidden graph. So in that, how much hidden layer weights to be contributed to error, that one we need to calculate here. Same thing. So whatever that whatever we are getting the weights of multiplication of weights and uh, that d output. So here same thing, we need to calculate a hidden card, multiply with EH with the hidden card. Okay, so here that is, this is for hidden layer values. Okay, so after getting that hidden layer values, we are applying that we need to apply the weights. Okay, so we are weights with the learning multiple dot matter dot product of next layer and the, okay, next layer and the current layer. Okay, so we are applying the dot product for next layer and the current layer. Okay, so by multiplying with the learning rate. Okay, so by multiplying with learning rate, so we are getting a we are updating the weights. Okay, so then okay, so when you are getting that w updating weights, so here we need to multiply with input. Okay, that is transpose of the input with whatever we are getting the hidden layer values. Okay, so multiplying with input whatever we are getting the hidden layer values, when you multiply that learning rate, we will get the updated weights. Okay, so we will get the updated weights. Then that updated wh will be the that updated weights will be multiplied with the input layer. Okay, so like that the weights will be updating, and finally we will get a actual output we will get. So when you print x, okay, so when you print x, that is nothing but so the whatever the values we are getting now, so that values we are printing x and printing y, okay, and after that output. So here that is nothing but a, that is the x is nothing but a input, okay. So y is nothing but a actual output, and output will be the predicted output. So here when I execute these things, okay, so here this is the output. So here we have given the inputs, the 291536, that one will be converted into 0.66, 0.3315, and this the actual output we have given 928689. So this will be the actual rate 0.9 to 0.86, 0.9. After okay, so after applying that artificial neural network, we will get the predicted value will be 0.74. So instead of actual will be 0.92, here we are getting a 0.74. Okay. Okay, so here we are getting a 0.88, 0.8689, 0.8889. So it is nearer to our target. Okay. So like that, this artificial neural network will work. Okay. Thank you very much. I will end this session now.